Our lesson today is about Hooke's law. Objectives. At the end of this presentation, the student should be able to state Hooke's law, calculate the tension of the spring using T equal K times delta L. Equilibrium of a body. Consider the figure. The forces acting on the body S suspended from the free end of the spring as shown in the figure are weight and tension. When the body is in equilibrium, the condition of equilibrium is W vector plus T vector equal 0 vector. The sum of the forces is equal to 0. W vector equal minus T vector. The two forces have same line of action and opposite directions. W equal T. The two forces have the same magnitude. Elongation of the spring. Consider the spring. The initial length of the spring is L0, which is the length of unloaded spring. If we suspend a load of mass M from the free end of the spring, as shown in the figure, the spring elongates and its length becomes L, and the elongation of the spring is delta L. Then, L0 is the initial length of the spring, the length of unloaded spring. L is the length of the loaded spring. Delta L is the elongation of the spring. Then, delta L is equal to L minus L0. Keep in mind, to convert from centimeter to meter, we have to divide by 100. And to convert from meter to centimeter, we have to multiply by 100. Hooke's law. Consider the spring of length 20 centimeter. If we suspend a load of mass 10 gram from the free end of the spring elongates and its length becomes 22 centimeter. If we suspend a load of mass 20 gram, then the length of the spring becomes 24 centimeter. If we suspend a load of mass 30 gram, the length of the spring becomes 26 centimeter. Then, the initial length of the spring in this case is L0 equal 20 centimeter. The forces acting on each load are weight W and tension T. Condition of equilibrium. W vector plus T vector is equal to 0. W vector equal minus T vector. W equal T. Let's complete the following table. The mass in gram, 10, 20, 30. The length of the spring, L in centimeter, 22, 24, and 26. To find the mass in kilogram, we have to convert from a gram to kilogram. We have to divide by 1000. Then the masses are 0.01, 0.02, 0.03. To find the length in meter, we have to convert from centimeter to meter and we have to divide by 100. Then the values of the length are 0.22, 0.24, and 0.26. Tension of the spring. To find the tension of the spring, since the body is in equilibrium, then T equal W, then T equal M times G. Then the values of the tension are 0.1, 0.2, and 0.3. The elongation of the spring in meter. Delta L is equal L minus L0. Then the values of the elongation are 0.02, 0.04, and 0.06. After completing the table, let's calculate T over delta L in Newton per meter, which is equal 5. We conclude that the tension of the spring is directly proportional to its elongation, and the proportionality constant is called the spring constant or physical constant or stiffness constant K, which is equal T over delta L in Newton per meter, which is equal 5 Newton per meter in this case. As a conclusion, The tension of the spring is directly proportional to its elongation. The proportionality constant is called the spring constant or physical constant or stiffness constant K, which is equal T over delta L. And its SI unit is Newton per meter. Now we can state Hooke's law. Hooke's law. The tension of the spring is directly proportional to its elongation, where the proportionality constant is K, stiffness constant. T equal K times delta L, where T is the tension of the spring in Newton, K is the stiffness constant of the spring in Newton per meter, and delta L is the elongation of the spring in meter. Thank you.